Breaking news. At 0412 Coordinated Universal Time, observatories on 3 continents reported a synchronized anomaly that, until this morning, existed only in theoretical simulations. From the Atacama Desert in Chile to Mauna Kea in Hawaii, from the Canary Islands to Western Australia, instruments trained on a single interstellar object all recorded the same impossible shift. 3I Atlas changed color again. Not gradually, not subtly, but abruptly. Within a 12-minute window, its spectral signature lurched from deep crimson into a sharp, iridescent cyan, a transition no known cometary process can produce at that distance from the sun. Today, the impossible just happened. Moments ago, internal alerts were triggered across NASA and ESA networks. Emergency observation protocols were activated, and a message was quietly circulated among astrophysics departments worldwide, carrying a single line that sent a chill through the scientific community. This changes everything we thought we knew. If you want to stay ahead of the next cosmic update before it reaches the headlines, hit like, subscribe, and stay with us, because what we're witnessing tonight may not be a random celestial event. It may be something waking up. To understand why this color change has scientists on edge, we need to rewind, not days, but months, to the moment 3I Atlas first entered our awareness. The object was initially detected by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, during a routine sky survey. Its trajectory was immediately flagged as hyperbolic, meaning it was not bound to our sun. This was no ordinary comet. It was the third confirmed interstellar visitor ever recorded, following Oumuamua and 2I Borisov. But even in those early hours, something felt different. NASA's Jet Propulsion Laboratory confirmed the object's inbound velocity at approximately 57 kilometers per second relative to the Sun, nearly twice the speed of typical long-period comets. ESA's Near-Earth Object Coordination Center independently verified the data. Within 48 hours, the James Webb Space Telescope was redirected, joined by Hubble, the Atacama Large Millimeter Submillimeter Array, and radio telescopes across the European Space Network. From the very beginning, 3I Atlas refused to behave. Its brightness fluctuated erratically, its coma appeared asymmetrical, and most puzzling of all, its color profile oscillated between wavelengths associated with oxidized metals and complex hydrocarbons, materials rarely found together in natural cometary bodies. At first, scientists urged caution. Interstellar objects, after all, are by definition exotic. They originate in other star systems, forged under unfamiliar conditions. Unusual chemistry was expected. But then came the first shift. 72 hours before today's event, at 1903 UTC, the Pan-STARRS telescope in Hawaii recorded a subtle reddening of 3I Atlas's surface reflectance. Spectroscopy suggested an increase in longer wavelength emissions, consistent with organic compounds heating under solar radiation. This was odd, but explainable. 11 hours later, however, the Very Large Telescope in Chile detected a countershift, blueward, sharp, precise. The change occurred while the object was still more than 2.4 astronomical units from the Sun, far too distant for solar heating to drive such a reaction. Then the acceleration began. Tracking data showed a non-gravitational thrust acting on 3I Atlas, increasing its velocity by 0.18 millimeters per second squared. That may sound negligible, but in deep space it's enormous. No visible outgassing was detected, no dust jets, no tail asymmetry. It was accelerating silently. Within the next 24 hours, the object's shape appeared to change. Radar imaging from Goldstone suggested elongation along one axis, as if internal stresses were redistributing mass. The signal-to-noise ratio was low, but consistent across multiple passes. And then, 48 hours ago, the color changed again, from red to violet. This second shift lasted exactly 2 hours and 17 minutes before reverting to its previous state, leaving behind a faint afterglow in the ultraviolet band. No known natural process could produce such symmetry. No known comet behaves this way. That's when the emergency meetings began. Inside NASA's Goddard Space Flight Center, analysts gathered around live data feeds, running simulations at breakneck speed. At Caltech, computational astrophysicists fed new parameters into gravitational models, attempting to reconcile the acceleration with known physics. Meanwhile, at Harvard, a small team led by Dr. Elias Morgenstern began asking a different question. What if, he proposed during a closed-door seminar, this isn't a comet at all? His words were not recorded, but they were repeated. Across the Atlantic, at the European Southern Observatory, Dr. Sophia Klein noted something even more disturbing. High-resolution spectroscopy revealed narrow emission lines, so narrow they implied a controlled, uniform temperature across large regions of the object's surface. The temperature held steady at approximately 310 Kelvin, room temperature, in deep space. That finding was quietly flagged and classified for further review, because if true, it suggested internal regulation. The mainstream hypothesis quickly formed around a rare but theoretically possible explanation: exotic cryovolcanism driven by trapped volatiles reacting under tidal stress. According to this model, 3I Atlas could be venting different materials at different times, causing color shifts and subtle thrust. It was elegant, conservative, safe, but it didn't explain the timing, or the precision, or what happened next. At 0241 UTC this morning, radio telescopes in South Africa and New Mexico detected a brief electromagnetic pulse originating from the vicinity of 3I Atlas. The signal lasted 0.7 seconds. Its frequency swept from 1.42 gigahertz, the hydrogen line, upward in a smooth curve before cutting off abruptly. At first, technicians assumed interference. Then the signal repeated, exactly 173 seconds later, and again, prime intervals. The pulses were weak, barely above background noise, but unmistakably structured, not random, not chaotic, controlled. As the data streamed in, something else became clear. The pulses coincided precisely with another color change, this time into a deep emerald green, a wavelength associated with ionized nickel and copper compounds. Those elements require significant energy to excite, energy that, according to all known models, 3I Atlas should not possess. This was no longer random, one internal report stated. It was responding. Within minutes, the object did something else. It slowed. Tracking stations confirmed a deceleration of 0.12 millimeters per second squared, almost perfectly canceling its earlier acceleration. The net effect was stabilization, as if the object were adjusting its trajectory toward Earth. Not directly, not threateningly, but unmistakably its path shifted by 0.004 degrees, an infinitesimal angle that nevertheless altered its closest approach by nearly 300,000 kilometers. That adjustment required energy and intention. As news of the anomalies spread through secure channels, reactions varied. At ESA headquarters in Darmstadt, emergency briefings were convened. At NASA, access to certain data streams was temporarily restricted. Requests for confirmation poured in from observatories worldwide. Meanwhile, subtle effects began to ripple closer to home. Low Earth orbit satellites reported transient orientation errors. GPS timing signals drifted by nanoseconds. Amateur radio operators noticed unusual static patterns coinciding with the pulse intervals. In northern latitudes, magnetometers recorded faint disturbances, just a few nanotesla, barely perceptible but synchronized globally. Even wildlife researchers reported anomalies. Migratory birds altered flight paths. Whales deviated from known routes. No single effect was alarming. Together, they painted a picture. Something out there was interacting with our planet's environment. Back in the data, another revelation emerged. High-resolution imaging revealed that 3I Atlas was not a single body. It was segmented. 16 distinct regions exhibited synchronized brightening during each pulse event, as if connected by an internal network. Gravitational modeling suggested these regions were mechanically linked, yet no visible fractures existed. And then, at 0609 UTC, one segment vanished. Not drifted away, not dimmed, vanished. All sensors lost it simultaneously: optical, infrared, radar, radio. As if it had slipped out of our observable universe. The remaining segments continued pulsing, unperturbed. At this point, the debate within the scientific community reached a breaking point. Dr. Marcus Liu of Caltech argued vehemently for unknown but natural physics, perhaps a form of matter interaction we have yet to understand. History teaches us humility, he reminded colleagues. Every time we think something is impossible, nature proves us wrong. But others were less convinced. Dr. Morgenstern circulated a controversial preprint suggesting that 3I Atlas exhibited hallmarks of engineered systems: internal heat regulation, controlled thrust, modular architecture, and now signal emission. This does not mean intent, he wrote carefully, but it does suggest design. The paper was not published. It was archived, quietly. As night fell across much of the world, a second wave of anomalies struck. At 2133 UTC, the remaining segments of 3I Atlas emitted a synchronized burst of light, brief but intense, peaking in the ultraviolet. The flash was visible to Hubble and Webb simultaneously, despite their vastly different vantage points. Immediately afterward, the object's color shifted once more. This time, it wasn't a single hue, it was a pattern. Bands of color rippled across its surface in a sequence that, when translated into numerical values, formed a repeating series: prime numbers. The sequence repeated 3 times, then stopped. Inside control rooms, no one spoke, because this was no longer a question of exotic chemistry, it was communication. What does it mean when something from another star system changes color on command, emits structured signals, and adjusts its path with surgical precision? For centuries, we have scanned the skies, listening for whispers. We assumed that if something wanted to announce itself, it would shout. But perhaps that assumption was wrong. Perhaps the universe speaks softly. Perhaps it waits to see if we're paying attention. As I stared at the live feed, watching those bands of color fade back into darkness, a thought occurred to me. Quiet, unsettling, and profound. Maybe we're not witnessing the beginning of an invasion. Maybe we're witnessing an introduction, an invitation. As of this moment, 3I Atlas continues on its altered trajectory. Its next close observation window opens in 36 hours. Instruments are standing by, data buffers are full. Governments have not issued statements, agencies remain silent. But the object is still there, still changing, still active. And one question now hangs over every observatory on Earth. What happens when it changes color again? If you want to follow the next update as it unfolds, subscribe and stay with us. This story isn't over. In fact, it may only just be beginning.